It is 4:41. I apologize, everyone. We've had a lot of technical difficulties. Sorry about the room change also. Let's just say it's a person, we had another or RSO reserve the group after. So this is going to be the intro to a three-part workshop. Pretty much our first workshop will be the intro to data science. The second one will be intro to deep learning, which you'll learn how to build a deep learning model and about the differences between machine learning, deep learning, AI, all that cool stuff. So this is also our collab with AI UCF. There you go. These are the sections we'll be covering today. If I can actually, there we go. So we're gonna pretty much talk about why you should learn data science. It's pretty cool. We're gonna teach you guys about tensors and data frames and pretty much all that fun stuff. We're gonna set up your environment and we're gonna do some live coding and we're gonna explore a data set, real one I found. And we're also going to build a machine learning model using Scikit-Learn, pretty basic, nothing not like TensorFlow or stuff. And then we're going to pretty much wrap it up and do a preview. So yeah, these are the objectives that you'll learn: data science, tensors, data frames. You'll learn about core libraries, NumPy, Scikit-Learn, Pandas, Matplotlib, stuff like that. You'll learn about EDA and feature engineering, important in data science, and because this will be like, most of the times you won't be just doing deep learning, machine learning. You'll actually be like, you'll learn how to choose your model as well. And then we'll have some closing statements. All right. So why data science, right? This is pretty much data science is a combination of like computer science, statistics, calculus, all that fun stuff. And you're pretty much, what you want to do is you want to predict like something. You want to predict the value. You want to predict the future. You want to predict like anything using patterns that you find in your data. So usually you're given a data set, then that you find information from it, which can do action, which then leads to an action or a prediction, which then you can re-input back into the sequence, and you get data from that action. That's called reinforcement learning, which is pretty cool. We might touch up on it in our next workshop. And the example of like what you can use it for is analyzing medical data to detect disease early. So like you have a brain tumor. But the one example I use to get people hooked into data science is pretty much, there was Target, with a little no fun fact, uses pretty much, they give a pregnancy score to every single user. So if you buy, let's say, supplements like iron supplements, calcium supplements, some like cotton balls, and it pretty much creates a pregnancy prediction for every single user. Let's just say that it's actually so accurate that it can estimate your due date, like when you're going to arrive, which is like interesting. It becomes something ethical, like something, but it becomes an ethical dilemma. What Target used to do is it would send coupons to the user through the mail, like down to the like when their due date's happening, because they're able to predict that. And it's really interesting. So that's scary. But an angry man barged into a Target once, like literally middle of Minnesota, like this is Minneapolis or Minnesota, somewhere there. And he wanted to talk to the manager. And the manager had no idea because he's not part of the software team. He's just a manager at a Target. And pretty much this is quoted verbatim. She's still in high school and you're sending her baby coupons and clothes for cribs. Are you encouraging her to get pregnant? The manager pretty much then called to apologize later. And the dad said on the phone that he had to talk with his daughter, and it seems to turn out that there have been some activities in my house, which I've been completely aware of. She's due in August. I apologize. So that pretty much just like, this is the news article, how Target figured out a teen dad was pregnant before dad did. So this is like data science is pretty much like it predicted the future for this girl and something her dad didn't even know. So this is why you should learn data science. It's really interesting. There's also a bunch of other like examples of data science where you can predict 3D structures of proteins, and it's just a bunch of statistics and math, which is really cool. Now we're going to teach you guys, we're going to get you into a little intro to tensors and data frames. This is fun. There's also a paper, I think, by Washing Yu, which is a famous paper, Intro to Deep Learning, which looks something like this. Obviously, we will not be going into this. This is a mathematician's view of pretty much tensors. As computer scientists, we don't have to focus much on this, thankfully. What we have to focus on is that a tensor is a three-dimensional array, or pretty much any multi-dimensional array. It's a generalization. So pretty much, this is how you, like, if you read a computer science paper, you would read that this is the formal definition for tensor, just any dimensionality. I'll show you later. But a rank 0 tensor is a scalar. You guys know what scalars are, right? Yep, yeah, I hope you do. Rank 1 is a tensor. A rank 1 tensor is pretty much a vector or an array, because you can think of an array as a vector in a space. A rank 2 tensor is 2D arrays, which pretty much, we all know what 2D arrays are, LeetCode. And rank 3 tensors are pretty much, you take a 2D array and you stack to another 2D array on top, and then you stack another one. So a good example is something like this. You have a 2D array right here. Let me zoom in here. This little 2D array, like this, with columns and rows, and then you just stack upon each other. And this would pretty much just be a 3D array. A good example, well, like a reason why we use tensors are pretty much all data, like science, all data science and ML pretty much uses structured and numeric data, and pretty much tensors are the most efficient numeric operations that you can do with data. So data frames, this is something we'll also talk about together. Data frames are pretty much 2D arrays, which they're pretty much Excel sheets, which we'll show you later. But together, they're the backbone of Python data workflows, I'm just going to say. So this is a good example. How would you express an image as a tensor? Like, how would you do that? This is what you can do. You can say that you have a column like this. Wow, that did not want to do that. Right here. So we have our beautiful founder, Dylan, as an image. So this is how you would see a tensor in code. This is like a shape. Each tensor has a shape. A image is pretty much just 3 color channels, red, green, and blue. That helps make up a majority of the color in the color spectrum. And these pretty much, this isn't the scale, because this would be a 4x4, or this would be just a 4x4 image, which Dylan would have come out as that beautiful. But let's say, yeah, you can tell, okay, so yeah, you can tell that this is a shape 1. You can honestly get rid of the 1 and leave it as 4x4 by 3, which this is what this image would be. But what if I stack another image on top? Let's say I have our beautiful Adrian on top of him, right? So notice that the tensor changed to a 2. Why? Because we have 2 images stacked on top of each other, and you can pretty much do a bunch of calculations with it. It's pretty cool. We'll go into detail working with images in our intro to deep learning, which is our second workshop we'll be hosting when I get that done. So pretty much, yeah, tensors could be used to represent images, just any data, any columns or anything like that. And let's see here. For example, I have this data set right here. Like, how would, like, this is just a normal typical data set. This looks like an Excel sheet, right? Yeah. So how would I like express this? So I have the age, obviously, I have the health score, and I have the exercise and disease risk. It's interesting, like, how would I express it? So this is pretty much a 2D tensor, 2D array. You could express this as a 2D array. Or you could do something really cool, and you can plot the relationships variable. Like, this is all the features. We have pretty much 3 target features, which is age, exercise, and health score. And well, let's say we're trying to predict your disease risk. Like, how at risk are you of getting some certain disease? And this will be actual data. Yeah, we have pretty much 3 features and 1 target variable. So let's say we plot it. Voila. This is pretty much how that would be a 3D dimensional data set with actually that would be I believe a 4D, since you're able to express the disease. No, it'd be 3D. I'm sorry. But this is how you would express the data set. Here, I'll actually even show you how it looks like. So usually you can do this cool thing right here. Let me throw this up here. Wow, that did not work. Hello. Okay, sorry. Let me try this. Stop it. Okay, here we go. But right here we have the 3-dimensional. So this is how like the data set could be expressed. And you can see this is a linear, this like machine learning would not be used. Obviously, if you have more data points, I have like five or four here. One, 2, 3, 5. It'll get cluttered if you have more data points, and it'll be hard to tell relationships. So pretty much, this is how you can express a data set like this. If you have, let's say, more than like three dimensions, it's gonna be a lot harder to visualize because obviously, once you get past 3D, it's pretty much impossible. It'll be really hard to work with it. We're actually be working today with a data set that's 47 dimensions, or like 47 features. So we're gonna be excited for that. So this like, even if you look at this is a pretty linear relationship. You could do something like linear regression and figure out the what is it? You don't have to use like a complex deep machine learning model with transformers and everything. So let's go back here. Voila. So right here, you can see like in this data set, it shows you that a person who is 20 and has a lot of hours of exercise and their health score is, let's say, pretty high, has a very low projector. Sorry. This has a very low disease risk. But as I say, it's compared to a person who is, let's say, 70 or almost 70, has a health score of like 3 or 2, and has, like 0 exercise. You can see that they're higher in disease, or the risk of getting a disease, which like this is how we age and how the relationships work. You can see here. So it wants to set up the environment. Let's do that. All right. So how many of you guys? I need you guys to see who has VS Code installed. Okay, I'm sure most of you, hopefully. If you guys do not, I would go to VS Code. Let's see here. Yeah. Let me throw this down. This will be a lot of fun. This is the interactive coding. We'll see how fast it takes us. VS Code. I recommend downloading it. Wow. Pretty much just download for any your OS system, and then you're also going to have. I hope you guys who has Python installed. Okay, we're going to go to Python. You're also going to have to want to install Python, because then we're going to do a lot of cool stuff. Here we go. Where's Python? Right there. Python downloads. Pretty much just go here, download Python, and you'll see. Just click on this button and it'll download for your OS. So I'll let you guys do that real quick while I show you what we're going to be talking about. We're going to be working with. Let me create a new. Let me first showcase a very simple. So we're going to create a new desktop. We're going to call it Intro to Data. So you create just a random workshop, or is it a random folder on your thing, and then you're going to open up that folder in VS Code. So let me create a new window here. So we're going to open up the folder, and we're going to go to Intro to Data, and voila. So this is, I'll wait for everyone to, or I'll wait until most of y'all, I'm sure most of y'all have it set up. So here's what we're going to do. We're going to install, if you guys actually want to test to make sure that Python runs on your system, here's what you can do. You can do Python -- version and see what version you have. Obviously, I have a older one, I believe. Yeah, Python 10.4 or 10.14. So I recommend, once you have this installed, what you want to see, what you're going to do is we're going to change directory. So this is, this is a command line. Sure most of you know, or I hope. Let's see here. So we're going to press LS. This will show all of your, pretty much this is just like the files that you see here. And we're going to change directory into whatever. We're going to change directory into wherever you put the folder. So I put in desktop, and I'm going to go back into intro to data, and then we want you to be inside the folder, which you'll be inside the folder once you have the correct directory. So here's what we're going to do. I'll wait for at least like a minute until you guys download some Python. But here's what we'll pretty much be installed, or we'll be working with today. We'll be working with let me do this real quick. We'll be working with We'll be working with NumPy, which pretty much is the main way that we work with tensor. You could do a bunch of tensor operations. You could do a bunch of just linear algebra operations. It works with any pretty much n-dimensional array, and it has a bunch of low-level numeric tooling and linear algebra multiplication, a bunch of cool stuff like that. This is any data science like job, or like any data science job or machine learning job will require you have a good skill set of these. We'll be also working with Pandas, which is pretty much it's built on top of NumPy, and it's pretty much an Excel spreadsheet. You can think of it like that. Or it pretty much just provides 2D data frames. It's also it's also phenomenal for pretty much data. You'll do data exploration, data cleaning, and grouping as well. Matplotlib, which is how we're going to be visualizing our data. And it's pretty cool and it's customizable. And then we're also going to be working with Seaborn, which we might be working with that one, Seaborn. It's pretty much just built on top of Matplotlib, and it has a bunch of cooler features, and it looks nicer to clients and just managers if you want to persuade them. And then finally, for machine learning, we'll be using Scikit-Learn. This is what you'll be working with mostly primarily if you go into data science, unless you want to unless you have such a complex data set where you have to go into deep learning, but we'll talk about that. This provides a whole bunch of models, and we'll also talk about how to choose our model. And it has supervised, unsupervised learning, and it's phenomenal. We'll be working with that. So I hope everyone has Python installed. Let me go back to this. Okay, well, thank you. Spoiling. Here we are. But we have our little folder here. You can tell right here. What we're going to do is we're going to be working with Jupyter Notebook. Who here has heard of Jupyter Notebook at least? All right. Yeah. So I believe there's an extension you guys can install, IPYMB, or just Jupyter Notebook. It's with a Y instead. So you might want to install a Jupyter Notebook, and you also want to install Python right here. You also make sure you want to install Python. Wow, this one right here, by Microsoft, no other one. And yeah, should be about it. Unless there's something I'm missing. Oh, and a little quick tip for anyone working in data science. A lot of files you'll be working with are primarily CSV. So, or you could be working with others like JSON and a bunch of that. But I recommend installing Rainbow CSV, if it'll show up. This will pretty much make your data sets you'll be able to see, and it just won't be colorless and plain. It'll show you the column or the feature, and it'll show you the data at the same color, so you'll be able to distinguish which one's which. I'll show you this in a minute. So once we have our once we have this installed, what we can do is we're going to create a little data folder for now. This is where we're going to put our data. And we're going to, here's the fun part. We're going to pull up our command window. It's already there. Okay, good. And then we're going to run this command. What we're going to do, when working with a bunch of Python dependencies, when working with a bunch of Python libraries, typically they have dependency issues, and you want something you want a little environment that you can actually control and work with. So what we're going to do is we're going to install a virtual environment. This is primarily when you work on big projects, they have they'll have a virtual environment where they have all their dependencies, so it doesn't interact with, let's say, other dependencies from other versions. So what we're gonna do is we're gonna go Python -m venv, and then the name of it, I always do .venv. That's what you'll always see, but you can name it anything you desire, really. And then we're gonna hit that. It's gonna wait a bit, and then you can see in the back right there, it created a virtual environment. And this is pretty much just a mini Python interpreter that you have at your fingertips, and it won't screw up with your other dependencies. So now we need to install those packages. How do we install those packages? Well, we need to go inside of it. So for Windows, most of you guys have Windows, I believe. So the command for that will be .venv/ or whatever the name is, .venv /scripts/activate. And then it'll change to be, it'll say the name of your virtual environment, like instead of base. That's for Windows. For my Mac folks, what we're gonna do here is we're gonna go source.venv/bin/activate. And wow, I did not spell source right. Here we are. Source. Okay. And as you can see right here, it changed to my environment name. So yes. Yeah, sure. All right, yeah, there we go. Voila. So you can see right here, it says, same obvious code, okay. This is definitely small. Apologize, everyone, here we are. Okay, this should be a little better, and let me make the window a little bigger. But here we are, we're gonna have the virtual environment right here. This will be your name. So now that you're officially in the virtual environment, here's what you're going to do. We're going to install those dependencies. First things first, let's install the good old NumPy. Who doesn't love NumPy? Install Pandas, or NumPy. And you'll get to look like a cool little hacker. This is actually how they hack in movies, by the way. And it said installed. I'm going to upgrade my pip. You can upgrade your pip if you want. Here we are. I'm gonna upgrade my pip for now. But next thing we actually, yes, you. Oh, this is unfortunate. Yeah, sorry. Here we go. Here we go. And pretty much you should just get a requirement already installed or status or listen. Here we are. You're gonna run pip install. This is the command. Python supports a lot of oh yeah, you. Yeah. Yes. Let's say that this happens I learned this from experience, but pretty much I was working on 2 projects and their dependencies got screwed up. So I had to completely restart my base. This is because I have base. I worked with Anaconda, which is a data science tool you might learn primarily. But their dependencies, other projects' dependencies, if you work on the same, it'll conflict with each other. And then you have a bunch of dependency problems. You can't fix it. And then fun. So here's what, next thing we're going to do is we're going to install Pandas. This is pretty much right there. We have a little cool hacking scene, as you can see. Once that is installed, we are ready for our actually, we're going to also install Matplotlib while we're here. Install Matplotlib. So Matplotlib like this. And this will pretty much, you can actually see right here, if we go to .venv here, I believe it's library. You can see that we installed NumPy, Pandas. You don't want to touch them unless they're broken, because this is all set up for you. So we're going to be focusing on this. This is your little Python interpreter. Here, let me go back so you guys can see the command. Pandas is how you spell it. And then we have Matplotlib, which this will be our visualization library. So we're going to do that. Wow. I misspelled Matplotlib. I apologize, everyone. Matplotlib. There we go. So we're going to install Matplotlib. And voila. Now we're ready for our data preprocessing. What do we need? We need a data set. So who here has heard of Kaggle? Okay. I'm putting you guys on. Kaggle is one of the data, there's two data science or data set sites pretty much. There's Hugging Face, which is the professional one, and then there's Kaggle. Kaggle is what we're going to be using right here. Where is Kaggle? Right there. So you guys are going to want to go to kaggle.com. It'll look like this, and then you can sign in or you register. I'm already signed in. This is going to save you guys because I'm not signed in on this account. Let me go into apologize real quick. Let me drag out this one right here. This is my official one, Kaggle. Pretty much, Kaggle will show you'll be able to compete against other people. You'll be able to also grab data sets from pretty much any type of data set that you want. You can look up images classification, computer science, NLP, anything. So I found us actually a data set recently while I was working on this. This is going to be student stress monitoring. Aren't we excited? Student stress. So first thing we can do, what you'd want to do is you want to press download and then download as zip. I'm going to wait for everyone to lock in and get this ready. So you're going to download this as a zip. And then this will be in once it's done. Voila. It'll be in downloads. You can unzip it. And then what you're going to do is you're going to take this, and then we're going to throw these two data sets in here. We're going to you can drag them into data right here. I recommend data right here. So yeah, this is why I wanted you guys to use Rainbow CSV, because this is a lot better than just like, let me show you what this would look like without it. This is what it would look like, and it would not be pretty. And voila, or restart extension, sorry. Like that. What is this? This is not beautiful. So I recommend, this is why I recommend installing Rainbow CSV. So your CSV files will look like this, and you'll be able to see, like, you face any problems something. This is a lot of, we'll look at the data. But now we're going to be working with Jupyter Notebook. Is what I recommend. Name Jupyter Notebook. Usually in Python you have .py. We're going to be working with IP. So it's IP, Y, and B. Very interesting format, very interesting file extension name, but I didn't choose it. So this is what you're going to want. You're also going to, once this is pretty much where you should be right now. I'll wait a bit. And what we're going to do next is we're going to pretty much, let me actually talk about the data science. While everyone's getting ready, let me talk about the data science life cycle. Let me get rid of that. So this is primarily the life cycle that data will follow right here. You'll load your data, you'll clean the data, you'll perform something called EDA. What is EDA? EDA sounds like a complex acronym. It's exploratory data analysis. Pretty much you'll be looking at the data and you'll be using your brain to figure out what is happening in this data. What is it? What are the variable relationships? There's a difference between good EDA and bad EDA. We'll cover that as well. So then we're going to do some feature engineering, and then we'll train our model. And then integration, you guys can integrate this into, I know most of you guys are computer science and data science majors. You can integrate it in like a website or use it anything like that. Pretty much. Here we are. So we're here now. Here's what we're going to do. We're going to press select kernel. So this is your Python interpreter. We're going to load the Python environments, and then we're going to press the very top recommended should be the virtual environment that you named it. So yeah, I had named it .bmv. It could be anything that you desire. And now we're going to run a little very complicated piece of code to prove. Now you're also going to want to install. I apologize. You're going to want to install that because that'll pretty much install the kernel. Hello, ds1 workshop. Well, comma. Yep, there we go. Wow, I don't like that. Once this is going to take a bit to download, or yeah, pretty much to install, update the, yeah, there we are. hello Python. So if you see whatever the print function is, this will confirm that you have Python installed and everything works correctly. Yes, you. Which one? The virtual environment? Oh, the cell? Where you select interpreter. So right here, you should see a little icon that says select kernel. Yeah, you go to Python, I believe it was Python environments, and then your top one should be .vnb, which hopefully it is, or if you want, you can go and add one, and you go here, and then you go to Python or the bin, and then you activate, I believe it's Python 3 right here, or just Python. So this is your, pretty much this is what most data science jobs or just when you're working with data, IPYNB will be a lifesaver because I'll show you why in a matter of minutes. So we have our data, we have our environment. What do we need to do? We need to load it. So as any Python will have, any project will have, we'll need to import pandas. This is how we'll load our data. I use PD, you can use any acronym you want. So next thing we're going to do is we're going to go here. We're going to pretty much load let's actually analyze the data together real quick. We have what appears to be a categorical data set. Thank you. Pretty much we have our category, we have a data set that has the living conditions, basic, actually, let me look up the Kaggle, because this Kaggle will be a lifesaver. Here we go. Here we are. So we have it looks like, oh, they did the work for us. We have a psychological factors, we have physical, logical factors, environmental factors, and academic factors, social factors, and pretty much what we want to do is we want to predict I'm going to say, is it here? It's right here. It was very interesting to see. We're going to probably predict the stress level of the student based on all of this. So we're going to import pandas. We're going to run it. Hopefully we don't get any errors. Because there's a lot of dependency problems, especially when working with, nothing should be right. It took a really long time to install or to load. Okay. We're going to need to load the data set, right? So this is what we're going to do. We're going to pretty much say, I'm going to say this is the categorical one, and this is the quantitative one. So, or doesn't matter if it isn't. DF is data frame, and then we're going to read CSV. You're going to go into the folder, and then you're going to do stress dataset.csv. So we're going to annotate. We're going to say that this one right here is the categorical one, because it has words, and this one will be the quantitative one, which means numbers. So there's a lot of cool things we can do with pandas. Print the data frame, and this is what you should get right here. Notice it's built like an Excel spreadsheet. It's also, you can also consider a 2D array. That is okay. Thank you. So pretty much we have just a bunch of this, the categorical, and a bunch of words that we'll be working with. And then we also have our other data set that we need to load. So I'm going to call it quantitative. Okay. Thank you, AI. Then we're going to read, and then that's that one. And then we're going to load this data set here to stress level data set. So it's the same as this data / stress level data set.csv. Be a lot easier. So now we have both of our data sets loaded. Hello. They did not find it. It might have not found it. Yep, no, they didn't find. Where did I misspell it? Data? Second one, yeah. Data, there we go. Data set. So now we have both of our data sets loaded. Now I'm going to break a little convention here, and I'm going to say we're going to run some EDA. So EDA is pretty much exploratory data analysis. There's a difference between good EDA and bad EDA. Do not, for the love of anyone, make plots just to make plots. It's every single plot you make, every single thing you look at needs to answer a question. What do I do with my null values? Should I use principal component analysis? Should I, what should I do with duplicated values? Stuff like that. Or is there any duplicated values? And that's what we're going to be working with right here. So we're going to create a new code cell, and I'm going to call this one. So in Python, we're going to create a function def, and this one's going to be called. I'm just going to call it EDA. And then here we are. Let me see this. Okay. Here's what we're going to do. We're going to have an input data frame. And then we're going to have these are our conditions, or this will be our parameters or inputs. And this will be just name, which is just like that. Okay, well, thank you, AI, but we're not going to be using you. So here, what do we need to do first? First, we need to let's take a look at the quantitative data set. So we're going to call this function with quantitative data set right here. We're going to do quantitative data frame, and then we're going to input quantitative like that. So first things first, we're going to look at the data set shape. So this will be, thank you, AI. This will tell us the data set shape. So using our knowledge of tensors, how will this look like? So this is 1,100 rows. So stretch down, and 21 columns. So it'll be a 2D array of that shape. You can think of it like that. Then what the other thing we want to do here is we're going to want to actually drag this out. This is Matplotlib, annoying me. Here we are. Where is this? Okay, Kaggle, this can go. I'll let you guys catch up real quick. I'm going to drag this over since we won't be needing it for now. And here's what we're going to do. We're going to print the dataset shape. Then we're going to want to print the dataset dtypes. And this will create a new line. So I promise you, this will get very hectic. This will get very hectic. Print dataset dtypes. So these are, everyone knows what types are in coding, or like you have integer, float chart. Pandas uses, well, yeah, Pandas, most of the times you'll see them as if you say type of quantitative data frame, it'll show pd.data frame. Yeah. Pandas core data frame. Pretty much inside we can actually contain, and we can say that the input data frame .dtypes. Okay, I'm gonna have AI fill that because I don't want to do that. So this will show us right here. I'm gonna do this one by one. Wow. We're not going to shrink to a tuffle. Okay. So, okay. df.dtypes. Let me actually real quick. Well, good practice is to say df is equal to, we're going to copy this data frame. df.copy. And this will pretty much show that, let's see here, dtypes. Let's see, this is going to be live coding, which is very fun. Yeah, you're right. Data, I love data. Oh yeah, I can kind of, no, it didn't do that. Let's try just this.
For shape.
Yeah, shape. Shape works perfectly.
Yeah.
Which one?
Put a comma in shape.
Shape right here. Yeah, oh, perfect. Thank you. Yeah. Love you, man. So right here we have the, what is it? all of our these are the D types of our data set. Pretty much we have a bunch of integers and we're going to predict the stress level right here. We also want to use some descriptive statistics. So this is what we're going to do. Again, we're going to create a new line because this is most of these this will not look pretty if I do. Let me run that, make sure it works. Yep. Then we're going to print the data set description. And then, yep, there you go. AI filled it all. We're going to describe this will pretty much show us right here. You can use a scrollable element. This will show us. This is actually a really useful feature. It'll show you the mean statistics standard deviation of every single variable in the column. So here we are. We have let's say, yeah, you can see we have like the mean of anxiety level is 11, or is it 11, or standard deviation, or minimum, or max, and every single type of condition. So this is something you could actually explore you can like explore by yourself and try to figure out, see what variables are messing up or which variables have a unique, like have a low mean, a wide standard deviation, and could be considered unpredictable. And then we're going to just print the first five. And we're going to print -n, I believe we're going to do print